I'm glad to have the chance to talk to you about this issue of what does it mean to be a physicist and what kind of things does that empower you to do, what kind of things are you responsible to try to do, and is it fun? It's clearly one of the key questions that keeps your lifelong interest. So the physics that I'm involved in is started at the same time as my wife and I got a new son. That's 1960 with new lasers. Lasers can have something which was new to man, which is this business of having light that has coherence. And the amazing thing is that the light can have a wave that is so uniform that it can have not something as little as 1 million or the next 9 digits or the 12 digits, but now we're working with 16 digits of 10 to the power 16 waves that all have the same frequency, and they're, we say, coherent with each other. And that makes it possible to do measurements that are not previously imagined. What kind of measurements would be interesting? To measure the length of a pencil with such high precision is not very interesting. You know, the pencil will wear off and maybe the lead breaks. But some things really are interesting, and things involving physical parameters are important. So you can define the length by talking about the speed of light. So, and that brings us to the relationship then that you have a frequency for the speed of light and the wavelength. Or in undergraduate kind of physics, one has a velocity in meters per second. And from Einstein's work, we believe that this number is a fundamental number of nature. And on the other hand, now we have the measuring tools that let us get to the place where we can start wondering about the effect of gravity on these atomic physics phenomena. So my group is working with strontium atoms, a whole bunch of strontium atoms, maybe 10,000, that are all captured in something like an egg carton. We call it a lattice. Each atom has its own site. To a high degree, there is no empty places. So it's just a homogeneous kind of a first thinking idea about how you would like to get atoms together so you can see how they work. And this will let us check that Einstein, who chose assumptions based on their beauty and their elegance, and so far he has turned out to be right, but this time it's a little bit of a question. So the way that we're going to put the question is a satellite experiment. We're going to have two very stable sources. One of them is based on molecules, and the other one is based on having light that bounces back and forth between some mirrors. The mirrors are very highly reflecting, and using some electronic servo methods that I've developed, we can lock the laser on it. So again, we can realize 14 or 16 digits limited just by the stability of this material. Recently, it's been possible to use low temperatures to get out even the tiny little change in the length because of thermal vibrations of the mirrors. So we're going to be able to compare a clock defined in terms of a light speed, light pulse clock, which was Einstein's way of describing it, with an atomic physics or energy-based clock. So the satellite will be in low Earth orbit at some time and in high Earth orbit, that's to say an elliptical orbit, so the gravity will change quite a bit. And the dynamic change that one has with this clock now, just using the Earth's gravity, if we move the clock vertically by 2 centimeters, the frequency has to change. Well, the people that put up our GPS system knew that the frequency had to change. And those are very high satellites, so it was a substantial frequency change. And at the time, there was even a discussion about what was the sign of the frequency effect. But this is a really interesting kind of place, and it's one of the first and most powerful tests that will come on this Einstein equivalence concept, that gravity should work on everything with the same influence. We'll see. I look forward to it. Of course, my years are running too fast. So there's a bunch of young people, a lot of them in other countries, because for a moment the United States doesn't seem to be quite as wise in how we're spending our resources. But Europeans, and I hope African students will be part of this. One totally marvelous thing is that people from Saudi Arabia are now part of this program. And so we'll see how it all goes. Oh, the Nobel experience. Yeah, that's something which is unexpected by most people, I think. One should understand that there's a lot of people on the earth, and out of that, a lot of really good people are working hard to do science, just top quality stuff. So how these people that live in isolation in Stockholm can figure out to pick up to 3 people in each field, that's a terrible responsibility to me. But one of the ways that they've chosen is to pick on things which really change what tools people have that are doing the research. So I came along just following my nose to do the next thing that I needed. And in order to get more precision, I needed to be able to measure the frequency better and over a wider range. And so we started working with combs of optical frequencies that would have a bunch of them, and they would all have the same interval between them. And we made that with a synthesis method with microwave modulator, and I put microwaves in, and of course that will show up as the splitting between all of these different optical frequencies. And this, I've got to tell you, is the hard way to do it. And other people were coming from a different part of the universe. They thought it was fun to have powerful lasers, and then you can have enough energy to really do something. Maybe even start a nuclear power, fusion power plant. But other people are trying just to see what is the shortest pulse that you could have. So it would be interesting to have many, many short pulses and have them at a very steady repetition rate. So this technology came, and then their power was high enough that interacting with some crystal system designed by people, but using just normal materials, it was possible to create a whole comb of frequencies by that. And that really made it possible to make frequency measurements better, and frequency measurements are the best we can make. So this was a good subject by accident that I started to take an interest in, and so other people take an interest in it because they realize that it just gives enormous power. So you get a call, and you won't be in the same time zone as the people in Stockholm. They're likely to announce it at 11 a.m. and you'd better be rested up if you're in danger, because in Boulder, Colorado, it came at 3:40, I think, or 3:41 in the morning. My wife hanged the phone up a few times because we thought this was a Central American phone scam business that was popular at that time. So, but anyway, they persisted, and they asked for Dr. Hall finally. And so then Lindy made me aware of it. And By that time, the newspaper people knew about it, and reporters were coming, and it was a little bit congested. So,
All right.
anyway, it's a grand party. If you get a chance to go, I would recommend you
Sure.
one time.
Oh, thank you so much, Professor.